All right, now let us discuss about rational functions. So the definition is very important in mathematics. So first you have to understand the definition of a given function. Now, a rational function is any function that can be written in the form of f of x and n of x divided by d of x, the numerator over the denominator. Or sometimes we write, f of x, the top function divided by the bottom function. And, the bottom function should be different from 0. So the other important things are both n of x and d of x are polynomials. Otherwise, it's not a rational function. So the numerator as well as the denominator must be polynomial functions. And the domain of a rational function is not the set of all real numbers, but it depending on the value of, the x's that makes a function undefined denominator. So it is not like a polynomial function, but you have to look at the denominator, and the denominator should be different from 0. From that one, you can conclude the domain of a rational function. So look at these are examples of rational function. For example, the first one, look at this one. Now, f of x is x minus 3 over x minus 2. Now, in order to determine the domain, the domain of this one is x minus 2 should be different from 0 and x should be different from 2. So this is the domain now, domain from negative infinity to positive 2 union 2 to positive 2. Now the line x is equal to 2 is known as a vertical line. A vertical line. That means you can approach to this vertical line, but you can't cross it. Never. That is just assume that there is a vertical wall, so you can't able to cross the vertical wall. So that is known as, a vertical line, which is known as a vertical asymptote. A vertical asymptote of the rational function. If you look at the second one, f of x is equal to 8 over x squared minus 4. The bottom one, you can look at 8, you can write x plus 2, x minus 2 form. Then, this one, the domain is x should be different from negative 2, x should be different from positive 2. But you have to write interval notation. For example, this function is not defined at negative 2 and positive 2. Interval notation, you can write negative infinity, negative 2, union, negative 2, 2, union, 2, positive infinity. In other words, the function is not defined at these pointers, but it is defined on the red pointers. So when you draw the rational function, you have to indicate the vertical line. So this one is also a rational function, and 1x plus 1 over x. In that case, there is a line y is equal to x, which is known as slant asymptote, which is different from the vertical asymptote. So there are 3 rules to find the horizontal asymptote and the vertical asymptote, or whether the graph of a rational function has a slant asymptote. So we'll see this one. For example, there are 3 procedures. For example, vertical and horizontal asymptote of rational function. Vertical asymptote, suppose n of x and d of x have no real 0 in common. If c is a real number such that d of c is 0, then the line x is equal to c is a vertical asymptote of the graph of f. And if n of x and d of x have one or more real zeros in common, cancel common linear factor and apply case 1 to reduced fraction. The reduced fraction has the same asymptote as f. That is for a vertical asymptote. The horizontal asymptote, there are three cases that you can find the horizontal asymptote. The case 1, if the degree of the numerator less than the degree of the denominator, then the horizontal line is equal to y is equal to 0. The second one, if the degree is equivalent to the degree of the denominator, then take the the ratio of the leading terms. And case 3, if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. So I'll give you case 1, case 2, case 3 examples to identify the horizontal asymptote. For example, if the rational function is given by, let's say, x over x squared minus 9. In this case, the degree of n of x is 1, degree of the denominator is 2. So we have to use case 1. Says that if n of x less than d of x, then the horizontal asymptote of this one is 0. That is. And vertical asymptote, you have to determine the vertical asymptote. The vertical asymptote, which is x squared minus 9 is equal to 0. So x is equal to plus or minus 3. That is, one line is x is equal to 3. The other line is x is equal to minus 3. So you have two vertical lines. So this is the first case. Let's see the second case. Let's see, this is 1. The second case, let's say f of x is equal to 3x plus 5 divided by minus 4x plus 9. Remember, degree of n of x is 1, degree of the denominator is 1. Now case 2. Now case 2 state that case 2, if n of x, degree of n of x is equivalent to degree of the denominator, then the horizontal asymptote is equal to a over b. In our case, y is equal to 3 minus 4. That is the horizontal asymptote. However, the vertical asymptote should be determined from the denominator, right? The denominator set to 0, minus 4x plus 9 is 0, minus 4x is equal to minus 9, and x is equal to 9 over 4 is a vertical asymptote. The third case, I can give you an example. For example, assume this is a rational function. Let's say 3x squared plus 2x minus 5 over x plus 1. In this case, do you see degree of n of x is 2, degree of the denominator is 1. So case 3, degree of n of x is greater than degree of denominator, then in that case, then there is no horizontal asymptote. But we can find the vertical asymptote in our case here. Vertical asymptote, you have to set the denominator x plus 1 is 0, x is equal to negative 1. So we'll see what will be the behavior of the rational functions when x is approaching the vertical line from the left and the right.